Good morning. I'm going to start a new chapter today, chapter 7. And I'm recording this session not as a class presentation because I'm not going to be here Thursday morning, first period. I have a dental appointment. So I'm recording this ahead of time. So hopefully you guys in period 1 will view this before you come to class on Thursday, because on Thursday it'll be in-class work that you have to turn in. I'm going to run it the same way for periods 4, 5, and 6, even though I'll be here. I'm expecting the students to have viewed this video and be prepared to work in class on Thursday, but I will be there on Thursday to help you guys out. Okay. So the topic is all about solving systems of equations. So you must have come across the term systems of equations. You just kind of scroll down on this thing. So first of all, what do we mean by a system? It means really more than one equation. Okay, so for example, 2x plus 3y equals 5 and minus 4x minus 6y equals 7 is called a system of equations because there are two variables and two equations to solve. And there are three basic methods of really solving these equations, and we'll go through each one of them as an example. So the substitution that you must have learned before, there's elimination, and in the context of linear systems, it's also called linear combo, or linear combination of equations to eliminate a variable. And then the third method is the graphical method, which is really graphing the equations and finding the intersection points. Obviously, the last one's best done with a graphing calculator, but I expect you guys to be able to do that without a graphing calculator. So for my first example, I'm going to do number 19 on page 495. So let's take a look at what that is. Guess what? This is from the old book, so let me just kind of wing it and look for another problem on page 481. So this should be page 481. Okay, and I want to solve by substitution, and then I have to check using the end box. Okay, so let's say I do number 13. So number 13 on page 481, and number 13 reads x minus y equals 0, 5x minus 3y equals 10. So the method of substitution involves taking one variable, isolating it from one equation, and putting it into the other. So this one's fairly easy. It's fairly easy to see that x is equal to y. Okay, and so if I want to substitute, I can place in place of y out here, I can put x in there. Okay, so then I would get 5x minus 3x equals 10, which gives me 2x equals 10, which gives me x equals 5. And since y is also equal to x, y is equal to 5. So your solution should be written as an xy pair, and so your answer is 5, 5. Well, it's really smart to check this out and make sure it's working. So let's take 5, 5 and put it in this equation. It's fairly obvious that the answer is 0 on that one. That's fairly obvious. Let's do it on the other one. So I get 5 times 5 minus 3 times 5. That's 25 minus 15. That's equal to 10, which is equal to the right-hand side. Okay. So that's great. So it works out okay there. And then the question wants you to check this on a graphing calculator. So let's go do that. Okay. Make sure your calculator is in function mode, because we've been playing around with these modes. Make sure you put it in function mode. You go into y equals, and you start entering the equation. So remember, you'll have to isolate the y variables. So here, if I isolate it, I get y equals x. And if I isolate it here, I get y is equal to 5x minus 10 all over 3. Okay, so those are your two equations that you need to put in your end box. So the first one's easy, y equals x. The next one is parenthesis 5x minus 10 divide by 3 and graph that. Okay, so there is y equals x. there is a second equation, and I want the intersection point. That's the point that I want. Okay, so let's go do second calc, and I can go intersect, which is number 5, and move the cursor closer to where the intersection is. So your cursor is now on one line. Let's just go hit enter there. It's on the other line, and it's pretty close to the intersection as well. Enter there. I don't know what the answer is. I want to estimate, so I'll just enter. So here's your intersection point. It tells you right there. Okay, intersection is 5,5, which is what we had here. Okay, so that's good. So we can use the graphing calculator to check that. All right. Moving on to the next question. Oh, I guess I had the equations down here, but anyway, so the ideas are very similar. Okay. The next question is solving by elimination and checking using the graphing calculator. Okay, so let's start working on this one here. Notice that the question number and the page number are from the old book, but the question has been repeated here, so it shouldn't be much of an issue. Okay, so to do elimination, since we are fractionally challenged, I'm going to times this equation by 10, just to get rid of fractions. Okay, so then my top equation becomes 2x plus 5y equals 80, and my bottom equation is x plus y equals 20. So I have two equations with two variables. Okay, and I'll write them as equation 1, equation 2. What I'm going to do next is I'm going to eliminate, let's say, the x variable by timesing the bottom equation by -2 and adding to the first. So if I times the bottom equation by -2, I get -2x minus 2y equals -40. And there's my equation number 3. Okay, so this is actually timesing by -2. And now I'm going to add 1 and 3, equations 1 and 3. So if I add, the 2 x's disappear. I get 3y equals 40. Oh, that's a kind of ugly number, but that's life. So y equals 40 over 3. Okay, y is equal to 40 over 3. Let's make sure this is okay before I proceed. So that's -2x minus 2y. It's minus 40. If I add the 2, I get 3y, and that's 40, and y equals 40 over 3. Now to get x, it's probably best if I use this equation. Okay, if I use this equation and plug in for y equals 40 over 3. So I get x plus 40 over 3 equals 20. So x is equal to